Okay, so we are going to have a presentation about scalable blockchains from 3 people from BSV. Thank you for coming, and we can start.
Thank you.
Thanks so much.
Haristo. Thank you for having us. This is really exciting. So we represent the BSV Association, global advocate for the BSV blockchain. I'll give an overview. This is everything we're going to handle, but seeing that there's a mix of a big audience, let's keep this interactive. Thing that I'm saying or Siggi or Darren saying and you don't understand it, or if it's too easy, we'll just skip through it because we have sort of one generic overview. Then we dive into what is the importance is the scalable blockchain. And then that's Siggi's area of expertise on the node layer. And then we go more on the application layer, in the middleware layer, what the implications of a scalable blockchain has, because it introduces extra challenges like specialized indexing and stuff like that. So you need to rethink the architecture. So who are we? I'll start with this first. So my name is Ásgeir Óskarsson. It's the easiest to say Ás. It's the easiest. Siggi is sitting here, is our CTO. We're also brothers. So out of the 20 people at the association, there's 3 brothers there. It's just a brother from another mother, we would say. That's Darren. He's based in Texas. We're both Icelandic originally, but living in Switzerland. Headquarters is in Switzerland. And we have a group of 20 people. And the BSV Association is a non-profit. We're based out of Switzerland and we're focusing on education and awareness of BSV blockchains. So we work a lot with universities, with technology partners, and the pillars are, say, education, our own platform, but also working together in partnerships and making sure to spread the message. But also we've started, since we took over in January, we've really started opening up to the ecosystem more, right? We're collaborating with other blockchain associations, with other layer ones, with, say, the typical application that you have that you'll find on blockchain, because what the BSV blockchain offers is quite unique, because it's a Bitcoin protocol that has taken all the sort of artificial limits away. Like there's no limit on block size, there's no limit on script size, there's no, and that's, Siggi will go into that in more detail. And the beauty of that is that you can really achieve what the white paper was intending to do, is the peer-to-peer electronic cash system, and truly peer-to-peer. And Darren will go in more detail on that. So our mission is essentially to spread that message, to help the adoption of BSV blockchain as a technology, and really as the underlying infrastructure layer. Think of blockchain as the integrity layer that provides this trust, truth, and transparency under everyday processes. So that can be settlements, it can be financial use cases. One of the things we're really focusing on as well is working with businesses in supply chain, in healthcare, in retail, because the opportunities are literally endless if you just have this layer of trust that you know you're never going to run into any network congestion, any variable fluctuation fees or gas fees. So that the technology is really amazing to do that thing. So we're working with enterprises. This year we've sort of shifted our focus to working with and for enterprises and small companies to help them build it, essentially make it easy for anyone to build on BSV. And that's why we have Siggi's team, around 10, 15 people that are just building out POCs and case studies. And the last 2-3 years have been sort of very hard work to sort of make that stack ready. Darren will go into that. But the beauty of that is by now we can push out POCs and pilots and reference implementation in a matter of hours, a bit more complicated days, and if it's really complicated, some weeks, but we can really start pushing out. So we've sort of now planted the seeds, and next year we really want to go ahead. So that's a bit about us. I need to go the other way. If you have any questions, just anytime, jump in. I think I already went in a couple of things. What we do is, it's the Bitcoin protocols. You had BTC and you had Bitcoin Cash, and the BSV is a fork of Bitcoin Cash. We ourselves say that we are the original protocol. We represent the Bitcoin design as it was in the white paper, right? So it's taking away these limits. So the Bitcoin protocol between 2009 and 2017, 18 opcodes were disabled. The block size was limited at 1 megabyte. I've only recently joined. Siggi and Darren have been longer in the space. So if you want to learn more about that, essentially there was a community disagreement on the block size, right? 2017, 18, and there were different camps. And in our case, what we advocate for is this unlimited block size, right? Because then you can get truly scale. So what Siggi's team did is we had our testnet running for 2 weeks at 1.1 million transactions per second on layer 1. So there's no layer 2 any needed. It's just plaster solutions on top of an artificial scarcity. We believe that you can really enable that on the layer 1. Also, opcodes have been restored, which means that you have much more programming functionality within the Bitcoin script. And the protocol is stable. So the scalability is one thing, it's the block size, and obviously what comes with Bitcoin is the UTXO model versus the account-based model. So there's parallelization, right? So you can do much more activities on the same time. And the security comes by the proof of work. It can be energy intensive, but obviously because of this high block size, you get a much higher throughput. So it's essentially you have the same rails that are costing energy, but the wagons riding those rails are just much fuller rather than just on 7 TPS. So that's where the more sustainable proof of work. And it's a public permissionless layer 1 blockchain. I think that's super important. It's a public blockchain. Anyone can join, anyone can build, anyone can do anything on top of it. And the beauty of public blockchains and also Bitcoin, and what Darren will go into it, is you can achieve privacy on a public blockchain. It's only a concern with governments. They're like, oh, they had this tendency to go towards private blockchains. We see it now that goes back to public blockchains, because public blockchains, you can achieve everything you want and more on and have that more transparency. So I'm going to run through these pretty fast. I think maybe you already did some pre-reading. But essentially, with Terra, we have 1 million transactions per second. We have implemented SPV, so I think it's section 5 or 6 of the white paper, which is SPV. 8 simplified payment verification. That's the one that truly enables peer-to-peer. Darren will go into more detail on that. Low transaction fees. I think we're now at sub-cent transaction fees, which makes it super suitable for micropayments. And especially if you think of the potential of intersection of AI and IoT and blockchain, you're going to need these low fees if you want to do machine-to-machine payments, web-based micropayments. You're going to need to have low stable fees and a stable protocol. So the is behind this is that you don't want the protocol changing, because you don't want any transaction that you put on chain today to no longer be valid. Right? And you run into issues. You want to have this long-term stability. If you, for example, have a trust-based business on your blockchain, and you need to make sure that the transaction you put on chain today is still valid in 10 years. Probably going to on this for sake of time as well. But essentially, it's a topology. It's the node software at the core, overlays, and SPV at the top. But Darren, you will go more into detail on that. So I'm going to skip that one. A lot of here is a duplicate, to be honest. I think I already said all of this, but the idea is to implement it in its original design. Bitcoin was designed as peer-to-peer, and for that you need scale. You can't support. We're from Iceland. Iceland on a Black Friday needs 100 TPS to actually do payments. You can't do that, and that's just Iceland. We're a very, very small country. So if you want to have truly peer-to-peer transactions on a global scale, you need to have the scalability on the protocol. Does anyone need explanation on proof of work, how it works, or are you all familiar with that? All familiar? Good job. And I'm going to skip that because they have the really cool stuff. We always say, I have the easy job of explaining sort of the basics. They have the hard job of explaining the tough stuff. So we're going to dive into the tough stuff as well. But essentially here, saying if you essentially the same network, trying the consensus model, but with much higher TPS. So energy consumption, if you're running at this scale, is less than a Google request or a ChatGPT request. So then obviously the sustainability narrative is much different. Native tokens is the same. So essentially you have 21 million BSV. The halving is happening every 210,000 blocks. there's no issuer, so it's software that is issuing the token to the miners as a block reward with every block that they mine. The lowest denominator is the Satoshi, 1 sat, and therefore you have 2.1 quadrillion Satoshi. This is fixed, and there's no intention ever of increasing that because the total supply is just capped. It should be sufficient for the global use of blockchain at scale, and then obviously you can have layers on top with other types of tokens, which we'll go into later as well. I think this is an important one to understand, which is also representing our philosophy a bit. The block reward is diminishing with every halving, right? So every 210,000 blocks, what miners get as a block reward for each block is going down. We're now at 3.125 BSV per block as a block reward. What that essentially is that going forward, this is going to go down essentially to close to zero, right? Which means that for miners to have skin in the game, to keep on being incentivized, you're going to need this transaction volume. You're going to need to have high volume of transaction fees for them to actually make sure that their business is profitable, right? So this is diminishing. So either then that means that this token price needs to go up to a ridiculous amount, or you need to make sure that the miners are incentivized by transaction fees. Went into UTXOs. Essentially, what it enables is it's the same as if you take Ethereum, which is an account-based model. You essentially have a bank account, and on that you have amount X, right? Which makes parallelization really hard because you can't really check whether it's something you spent. So you need to have a lot of logic in there to make sure that you're not double spending or doing something that you shouldn't be doing. UTXO model is essentially your wallet with cash in, right? You have a lot of bills and coins, and you can spend them separately from each other. So if you spend a $5 coin, you know you still have 10, which you could spend elsewhere. So it enables parallelization and therefore scale. So I'm very interested in hearing your topics on scale as well. This, I think, we'll skip unless you want to go into it. Essentially, it's a bit, what does the transaction contain itself? So with UTXOs, the U means unspent. So it's an unspent output that is ready to be spent elsewhere. So once you spend it, you point to the other one, and then say you have X UTXO, you can have multiple inputs and outputs. And at one point it's just spent, and then it's no longer there, right? So then you have no UTXOs left. So you can go into more of that, how that's been handled at scale, because that also at scale, that is also another consideration to take into account for architecture. As we already did, running through this is an interesting concept, and it's not necessarily that, but I just want to make sure that it's in your heads as well. You don't need to put everything on chain. It's a matter of also business efficiency. If you want to put big transaction or big data on chain, your cost also goes up because you're paying by kilobyte, right? So depending on your business model that you're actually implementing, whether you want to have everything on chain or you just want to have the fingerprint of a certain set of data on chain. We're working with businesses in the data security layer. You don't need to put that entire file on chain. It would, and then your cost would be depend on the file size. But actually, they do is they put the hash of that file on chain, which makes your business model way more effective and efficient. And in the overlays, essentially where you have your off-chain data storage, and you just have the integrity mapping. But again, that depends on your business model, what it is that you want to do, and if you want to, what the type of data sharing needs you have. But it makes everything much more cost effective. It's also regulatory compliance. In the European Union, for example, there's now voices going around personal PID or GDPR rules. PID on public blockchains, it's a concern that they have. So as a sort of best practice, just never put any sensitive personal identifier chain, right? So you can always keep them off chain. And what this enables, this overlay concept, is essentially that you can have these private permissionless capabilities on a public blockchain. So that's super, super important to know. That's the biggest takeaway on this one. And if you look at identity, I think that's the key to everything, but I'll leave it also to Darren to go more into that, and then we can go more into details and make it a bit more interactive. But there's various ways of how you can handle the identity on BSV. And then there's tokens. So you all know of NFTs probably. There's fungible tokens, there's NFTs, whether they're unique or not. But essentially a token is nothing more than a digital representation of something physical, right? And I'm just going to highlight this, which is the one-sat ordinals. And you may know in the BTC world, there's a lot of hype now around ordinals as you that for a token. Different is that the minimum number of sats in a BTC transaction is around 500, I think 516 or 526. We have a concept called one-sat ordinals, where you actually can have an NFT on chain, and it's going to cost you one sat. And Darren can go a bit more into the ordinals part because we have that integrated into it. Essentially enabling you on top of the stable protocol to actually have NFTs and tokens. And again, those tokens can be anything, could be loyalty tokens, could be a stable coin, could be an artwork, could be anything really. That's the beauty of it. So we really think of blockchain as infrastructure layer with the logic that can enable any type of business case or business model you want to think about. So this is the one-sat ordinal. So you can start minting yourself. There's actually a US dollar stablecoin that uses it. It's called money. So it's MNE, it's money. But essentially, it is the tracking of the token through references of the different UTXOs. And this is where it gets really exciting for me, because I get to do the easy job. The use cases are endless. So you can do so much on blockchain, and we have now as our sort of theme or branding together towards better, which is sort of representing our culture of opening up and working closer to the ecosystem and with partners and universities, etc. But it's also think of the opportunities that we have as a society to improve the world, like make it fair, make it more transparent, and make it more trustworthy. Trust is a big topic at the moment. I was at the VEF last year. The biggest topic is that people have stopped trusting media, stopped trusting government, stopped trusting enterprises. With a blockchain-based digital economy, or at least supported by blockchain, we can change the world. So you guys as students, you're the next generation. There's so much potential. It's really mind-blowing. So you can think of financial cases. So it's essentially banks or say financial institutions moving away from the old school mainframe COBOL world into a with T+3, T+7 settlements, where essentially you pay something, you get paid 3 days or 7 days or even 30 days from now. No, you can have that real time, instant. So that's in the financial case. There's also a company in the Netherlands that does real-time VAT settlement for all the companies with the Dutch tax authority, which is mind-blowing because it not only battles fraud, but it actually improves the traceability of VAT, and the government can have full confidence that they have it all under control. There's a lot of loss there as well. Then a big thing that I want you guys to remember is write down is digital product passports. It's a new trend coming in the European Union, new law actually coming in place next year, and they're going to expand that. Essentially, they want companies to be able to show the provenance of their products. So it's essentially you have a traceability solutions they're going to start with batteries, electronics, but they will move into textile, essentially. And it's coming from a sustainability angle. But if you look at it from a regulatory first, it's essentially looking at how can we make sure that this is authentic? How can we make sure that it's not produced under illegal circumstances? But if you think of it from a user perspective, there's a lot of potential as well, because if you think of it, well, this is not a fancy check, but if I had a fancy check and I want to resell it, I want to prove that it's authentic. For that, you need a digital product passport, because otherwise people need to trust me. And now they don't need to trust anyone because the producer has it from day one already built in. So there's a lot of cool use cases there. You can do it for supply chain management. So essentially you have, and that's one thing that I want to emphasize is the current supply chain is very fragmented. Everyone's sitting on their own bucket of data, and it's all in silos. And there's like APIs to make sure they connect each other, et cetera, et cetera. It's essentially a spaghetti of APIs. if you have this single source of truth, that's where the blockchain comes in, where they can share their data amongst any party involved. So you're creating trust where there's a trustless environment, so make sure that they can all track the same data. This is a company, again, in the Netherlands and Belgium. They're working with a local port in Antwerp, where they do automated sustainability certificates for every shipping container coming into the port. So they calculate the CO2 required, they do reforestation, immediate reforestation traced, and then they get the sustainability certificate once they've proven that it's in place. But outside supply chain and retail and finance, healthcare, and maybe not necessarily in the UK, but in other regions, there's more regulatory sort of appetite to actually try things out. So we're working with a company in Argentina to work on healthcare prescriptions on chain. And if you think of it, it's to battle fraud. So you have your identity of your doctor and of the patient. And the patient now could go into, because it's a handwritten note, he could go to pharmacy 1, get his drugs, go to pharmacy 2, get the drugs, to pharmacy 3 with the same prescription. So essentially what you're avoiding with this is a very elegant solution of avoiding a double spend and essentially making cost savings, but it's also just avoiding pandemic health issues because of abuse of drugs. So it's really elegant solutions. Then there's also this company is Switzerland, UK based, and you've probably in your studies come across like AI is now the next big thing, right? And people are trying to think what is the sort of, how does AI and blockchain fit together, right? And there's very beautiful ways with agentic AIs, etc. But this one's actually quite, I love it because it's so simplistic. Essentially, it's the AI that is making decisions autonomously. And because it's autonomous decisions, you need to make sure that there's some form of liability in there. So every attribute that led to a decision, plus the decision itself, is tracked on chain, which means that if the AI would make a mistake, you can actually prove it or prove that it wasn't the AI. And there's a company there in the farming industry, they've been able to reduce insurance premiums by 25%. So this essentially pays for itself because of that. And you could also think of cybersecurity, ticketing. Like I said, the opportunities are endless. So this is me bringing sort of the business angle of how blockchain can truly change the world. Because now what we're going to do, and I think this is very interesting for the people that are doing the research on scalable blockchain, now we're going to dive into scalable blockchain. And Siggi has been working on that for the last 2.5 years, is essentially bringing the node software from its current limitations to a over 1 million transactions per second monster. It's the closest thing to rocket science I've seen. So this is going to be quite exciting. So I'm looking forward to this one. The floor is yours.
Yeah. Okay. So before we go into the details,
Some of you are very technical, have a technical background. Right?
okay. No, I'm not going to go too much into detail. I also talked about a little bit in the beginning. What we're envisioning is we call it, used to call it a Mandela network, but it's like a network of services around the blockchain. What you see in a lot of other blockchains, they have layer 1s and they have layer 2s, right? So you have Ethereum's a layer 1, and then you have ZK-Sync or some other chain that's a layer 2. And we think that's problematic because the whole idea of a blockchain is to solve the double spend problem. So I'm paying Ásgeir something, I can't use the same coins to pay Darren the same thing. That is solved in the core, so there'll be the core node network. We go into layer 2, you have the same thing again. You also have to solve the double spend problem. So now you're solving on 2 layers instead of just one, and you have to group all these things together, put it on the layer 1. We don't do that. Most of the stuff actually happens in layer 1. So all the UTXOs, all the spending, all the double spend prevention is in layer 1. And then we have this outer layer of overlays that Darren's going to talk about, and then we have the applications. So this is a way of looking at the network that we're building, how to use the blockchain. Yeah, so overlay and the turn. Let's dive a little bit more into the technicalities in architecture. Almost all of the node software that's out there that's also based on what started with BTC, Bitcoin in 2009, is they're monoliths. They're single binaries that are run. There's a database, there's some storage, but it's just basically one thing. And the guys in BTC have limited the amount of transactions they process to 7 per second, basically, because of the block size. And technically speaking, there is no reason to do that, except what happens when a block comes in or something happens, the whole node lock. There's a lot of locking contentions and deadlocks. There's a problematic in having that one monolith doing all the transaction validation, doing communication to the network, or processing the blocks, all that kind of stuff. So what we did, we went back to the drawing board and we started completely fresh from nothing. I think it was about 2.5 years ago. And we thought, what are the different functions that a blockchain node is actually doing? So it's doing some kind of peer-to-peer stuff. It's getting transactions in, so something that we call propagation service. It's just too small for you guys to read. So there's a propagation service where just transactions come in, just does some simple validation, and then pushes further. There's a validation service that actually validates the script. So it's just inputs. I was talked about the UTXO. There's inputs and there's outputs, and there's a locking and unlocking scripts in there. Don't want to go into too much detail there, but there's a validation service to check that that's all valid. Then there's a UTXO store that actually validates that thing can be spent. So we can split all these things into different functions, and as much as possible make them horizontally scalable. This basically means that instead of running on one server, you can just ramp that up and run on more and more and more servers. And basically every time you add a server, you double the amount of servers, you double the capacity we can process. If you have a very, very well scaling system, we're not at 100%. I think we're about 90%. So every server that you add, every double will get you about 0.9 increase, so 1.9. But it's basically all split into different services. This is, of course, I mean, working with a blockchain, there's a lot of moving parts and there's a lot of complexities in there. So you have the digital signature, the hashing, you have the consensus on the network, you have to process. Now we have that inside the node as well. So this is a lot more complex than some of them that are out there now. Let's go back. So yeah, we split it into microservices. To get all these microservices talking to each other, there's some sparks, there's some things that they need to share. We actually went back to the stuff that we used a long time ago. And we're storing a lot on just file store. So like network file storage, some kind of shared storage. We actually did, when we did the test at a minus transaction a second, we're pumping everything also into S3. So there is services out there that will just ingest mass. They're cost effective. You don't do this yourself. So our transaction is something called a subtree. I don't think that's in this presentation to go into detail there.
What's S3?
Simple storage server. It's an object store in AWS. That's a fairly, I think that you will find that in any provider has some kind of S3 compatible storage layer. It's basically small objects that you can store. So there'll be transactions or subtrees or blocks. Then we have a key value store, which is storing the UTXOs. The most important thing that you need to do in any kind of blockchain system is to make sure that you're not spending something that's already spent. So you need to know is something spendable or not, and that's what happens. So this is magic happens. It's the heart of the whole system. What is the state of a UTXO? So it's expendable, it's already spent. What happens in a distributed system, we have lots of nodes talking to each other, is that so we all be a node here, and I'm going to send, I have this transaction I'm sending to him, he will send that to him. So these transactions are bouncing around in this peer-to-peer network, and they may arrive multiple times at your node. Be told multiple times about this transaction. And we have to, we want to prevent validating that again and again and again. But if we do, we want to make sure we're not messing up our UTXO store. So this is where the atomicity, you guys know that atomicity actually comes into play, that a thing is either spendable or not, it's either spent or not, or it's actually the same thing that we're not checking and we just need to return okay. But I mean, this is where the magic happens. And then we try to use, so when you're doing scale, this is very, very complicated. So we try to not reinvent the wheel in any case, introduce any type of new, very, very complex technology, because this system is just very complex. So what that's the file storage, and just simple SQL. So that's a Postgres database that's keeping track of all the block headers and things like that. So the key value stores, we ran at 1 million transactions a second, and that is absolutely insane. I think there are not a lot of companies that actually do something like this. There's some ad tech companies that have, you know, these kind of pixels on websites or banners, and they're tracking all of us, and they're all over the internet. They get these kind of numbers as well, but not many other companies do. And we were running on this is an AWS type of machine. 96 CPUs, 512 gigabytes, lots of disks in it. We're using 20 of those per node to distribute it. I don't think it's in this presentation, but we had, for every single node, we were running 6 of them. There was 3,000 GPUs and about 15 terabytes of RAM. I think you can imagine what kind of beast of a machine you need to run one of these things. But we ran it at 1 million a second. And actually, the database that we're using, so this is key value store. So every transaction is basically a bunch of inputs, outputs, and some extra metadata to tie it all together. And what we do, we hash that SHA-256 hash, and you get a transaction ID, which is unique. If SHA-256 works like we think it mathematically works, it should always be unique. There's never going to be a collection. We can use to also to distribute the data to different shards. So every transaction goes into one of these nodes, and it's based on the transaction ID. So you have very, very even distribution all over the clusters. That's very, very good. But these clusters are running at about 3.5 million transactions a second, or database transactions a second, because there were 1 million Bitcoin transactions coming in, and about 3.5 million transactions to do updates, and we also delete things. So if something is spent after some time, we can delete it out of the database. It doesn't have to be in there. So there's a lot of moving parts. There's a lot of things happening, and everything's happening at the same time. But this is the way that we scale it up. It's not very different. What we try to do is just use a lot of the technologies that already exist in scaling the web, basically to the blockchain. So a lot of the communication layers that we also have is just HTTP. We do have there's some peer-to-peer in there for some messaging, but if you want to get any data out of the node, it's just an HTTP request, because we thought that is the best way. And we even know how to scale that. We've been doing that for 30 years, scaling up the. So that's a big part of what we try to do here. An interesting mention here. I don't know if you guys are still doing something like that, but there's something called UDFs, a user-defined function inside the Aerospike database. Aerospike database. If you want to check out something cool, you should check out Aerospike. These guys have done something absolutely amazing. It's available. You can just use it as a community edition. I think the source code is also available. The speed of the database is basically the speed of your disks that you have. So there's the RAM, CPU, and stuff like that. It doesn't really matter. It's just how fast it is to write to the stuff. It's incredibly fast. But one of the things they have, UDFs, user-defined functions. So they're like stored. That says something to you. Like in SQL, you create this stored procedure that does a lot of logic before it changes something in the database. They have the same thing in UDFs, and we use that extensively for everything that we did. And the UDFs in Aerospike are actually in Lua scripts. So this is what my 18-year-old son is using to program his Roblox stuff. But we were using the same thing to run, the biggest blockchain node at 1 million transactions a second as well. Everything was being processed by Lua script. I think it's very fun to do. If you want more. This is going to be shared. These slides are already shared. So there's our GitHub. We can actually find the source code of the node. Everything's there. The documentation. There's the architectural design of the system and some interesting topics. We are actually open. So the code is open now. There's a testnet that you can run a very small testnet running on our laptops. Megan's running one. I'm running one.
BSV.
Our MD is running one as well. This is very fun. He's not technical, he's running one. But we're using that to test the consensus mechanism, stuff like that. So you can run it on your laptops and join in. It's fun. And you can see how the system works. You can play with it, look at the data. And at the same time, we're also going to be up again and doing a new million test in the coming months, trying to prove to the world that this is actually possible. A blockchain can scale. So did was last year and a half ago, 9 TPS. It was a proof of concept, so it didn't have all the functions and checks and balances and everything that you need to do have a full blockchain system, but it was doing all the work. So we proved that it is possible to do something. The only reason that we stopped at, I think, 1.1 million transactions a second is because it's very, very expensive. So you're paying for 3,000 CPUs and 15 terabytes of RAM to do that. You want to double that, and you double the CPU still. The nodes at AWS, I think they cost us $250,000 a month per piece to do this. So, but the architecture and the system, especially this UTXO design, this is not where it ends. This is where it begins. So it was a cost question of why we didn't go higher. So we often get, why should I care? But almost every enterprise on this planet has stopped thinking blockchain in a serious way. So how do I integrate blockchain into my operation? This was a question that was asked years ago, and they stopped asking the question because they say it doesn't scale. And if any company is going to use it, so Walmart is a company that does a lot of business with a lot of other companies. And there's something called EDI, which is enterprise digital exchange. It's some kind of data format they use in the supply chain to send messages between. So if Walmart needs some new ice creams from Unilever, some magnet, send a message. We need 2 pallets of ice creams presented. That stuff, if they would move over to the blockchain and those systems would start using the block layer of trust there, but they will not do the old system because they probably need 1,000 transactions a second to do all that everywhere globally to manage all this stuff. That is scale because we need to open the door again for people to think about the possibilities. We can run everything here. This is I always look at this, the most efficient transactions processing machine ever devised, and it's down to the smallest level. The actual transactions actually input out in the securities and the transactions themselves, not in your systems, not in your DevOps or your firewalls and all that stuff. It's in the transaction. So it's an incredible things possible. And you guys have to pick up now where we build applications. You're trying to build applications because we need new companies to be started, to do new things, because a lot of these old companies are not going to do it. And there's a better way to do things, but we need new startups to do it. Thank you.
Yeah, so my purpose is to distributed applications and helping people to make that a little bit easier, given that sort of complex architecture that's happening. So hopefully I'll give you an idea of something a little bit simpler at the application layer. So I like to draw cartoons to emphasize that it's very simple to actually build on BSV. So you have some sort of application web app that you're working on. It does some local host communication using our wallet SDK to the user wallet. So keys, private keys are distributed on local devices. And so when you're interacting with a web application, all key security is managed by the wallet, and you want to easily be able to interface into that. So really it's as simple as that to get started with BSV app development. Use that NPM package, instantiate one of our wallet client. It will sort of automatically find a local version of a wallet. So what it's actually doing there is it'll look on localhost on a couple of different ports, HTTPS, HTTP. It will see if there's a React Native post message available, which means we're in the mobile context, but it will actively search and find you a substrate to use for the interface between the wallet and the application and the wallet. What that means is you don't really have to worry about the cryptography. You don't really concerned about privacy key security, which usually puts people off developing on blockchains, because it can be a case of losing funds if you're dealing with those things incorrectly. So you can just kind of focus on your business application, or you can, let's phrase it this way, you can tell your Claude or ChatGPT or whatever to focus on the business application and just use that library. And that means you're going to be building something that's reasonably secure to begin with. So just as an example here, this is how we create a transaction, or it's phrased here as create action, because we're, human centric. We just want people to do stuff, and the technology is just underlying. So it's an example of an event ticket. So perhaps an event like this, you could issue tickets quite simply, in a millisecond like that. You could use a push drop token, and the idea there is that you can push some data onto the stack that you maybe read back later. It again just kind of simplifies the interface to that. Locking a token, you see your data fields in there. These are just ways to ensure you're deriving a new key for every interaction. You can use counterparty derivation schemes and so on. So to get started with this, the wallet that interfaces with can be any wallet that uses the BRC100 interface. So that was just an example, a couple of code snippets that do that. You can get a wallet here, and I'm sure this will be sent around so you can download that later. It's a bit of an explainer on the website in terms of what it's doing. And the snippets that you saw, there's a lot of those available at fast.brc.dev, which for some of you, if you like to just sort of play around with things to see how they work, that's where I'd advise you go. Reading our documentation, which can be long and boring. Okay, so as mentioned, overlays, which is really like a service layer entity. So you have applications which users interact with. You have the Terra nodes, which are doing all the heavy lifting of processing these transactions into blocks. And this service layer that sits in the middle allows businesses to find their own subset of this transaction. So you imagine there's 1 million transactions per second. No business is using all of those transactions, right? It's just that there are millions of people around the world. Each of them have different transactions that they're interested in for a specific purpose. So typically, if you look at other blockchains and at Bitcoin in the past, you'll see the model on the left being used. So I don't know if you can read my writing here, but the idea is that you sort of have a mesh node network, and there's a single broadcast API like in Fura or something like that. And all of the transactions go into a global listener, otherwise known as like a blockchain explorer. You can see any of the transactions, and then you go look them up to get your filtered transactions for your business application, which is a very small part by comparison. So over the last couple of years, what I've been trying to do is lead the team to develop the overlay concept, which means that users are doing peer interactions. They're generating these transactions and signing things. They're pushing them onto a specific business application. And the transaction is moving to an overlay that captures, let's just say, only event tickets. And so when they need to grab those transactions back, they're just pulling a Merkle path, which I'll go into explaining what that is, to prove that the transaction was included in the blockchain without having to have every single transaction, hundreds of billions of transactions validated if you've just got a handful for your event. So those are the Terra nodes in the middle, and these different colors represent different groups of overlay nodes. They could all connect together, sync transactions, so you've got some redundancy. Let's just say a specific service, I'll pick one out. So a message box, so just a simple server, you send it a message that's for a specific counterparty, and then they can go look it up asynchronously later. So you may have multiple instances of that, and you can send transactions to one of them, and it will propagate into the context of that overlay. Just also for technical reasons. Thanks so much. I'll maybe continue. I'll just be louder than my own echo. So again, just to reiterate, the idea is peer-to-peer transactions between phones. You don't need to be connected to the internet to do that. We can do it here in a bunker. And the transactions are done between peers, then propagated onto various services as and when needed. So we can pause. Yeah, absolutely. Does that make any sense so far? Yes, seeing one or two nods. Okay, great.
Should be good.
Yeah, thank you. So this may look a little messy, but the idea here is, you have multiple instances of the same services can be provided by multiple service providers, and you get some redundancy and robustness in the network. What we do at BSV is effectively build these functional components, which you can collect together into same problem again. Collect together into commercial services. And one of your questions might be, well, again. 1, 2, 2, 2. Thanks so much. Oh, great. Great. Okay, so yeah, why do we want to do this? This looks a lot more complicated than Web 2 stuff, which is just a simple back-end, front-end usually. What we're trying to do is to provide arenas for competition at every level. So you can now compete by fixing the interfaces between applications and the wallet. But what you can now have is people who are really good at database management might want to compete to provide database connection for wallet storage. Or perhaps someone is really good at UX design and actually just wants to build a front end for a wallet while still using all the standards everywhere else in the stack. That's now all possible because these open source components are available. Distributed, it just gives you robustness. That's the only reason why you would want anything to be decentralized is you have robustness. So if one node goes down, you can just use the other services. Standardized means we're not all reinventing the wheel. And the micropayment economy is something that's irreplicable, and this is to do with that extremely low cost. So I don't think my colleagues portrayed exactly how cheap this stuff is. So it's 30 millionths of 1 cent for a transaction. It's like insanely cheap because it scales. And of course, the reason we're involved as a non-profit is it gives this software vendor neutrality. So you're not being locked in. If you start developing on this, it doesn't really matter. The BSVA go away. It's all open source stuff. It's not like other platforms where you would have a specific company providing you easy to use APIs. But if they go bust, you're kind of stuck because they run all the infrastructure. This stuff you could run yourself. You can spin up an instance yourself if there are no providers available and start earning revenue. So you could become a commercial overlay service host. What we've figured out here is payments middleware. So you can pay per request to an API. You can pack a transaction into an HTTP request and actually pay for the response to come back to you. So 402 is a kind of common way to express this. So there's an unused HTTP response 402 which says payment required. So now we've implemented that into our SDKs. So you can make paid requests to commercial services. And again, very, very low cost. You could be paying for an image, or you could be paying per token in an AI stream, things like that. Other areas for competition would be running the commercial wallet infrastructure. So it's not expensive to run that, at least at low scale. If you're just gathering customers, you can start this sort of thing for £30 a month. And then you can provide storage services for people's transactions and metadata. Another area for competition would be if you're a UI designer or an entrepreneur that wants to build out a new product and vibe code something together. you could just use these blue components here, which are all made for you, and work on your business UI app, whatever that might be, and using the existing open source components here in blue that you don't have to build. So it's up to you. Whatever your skills are, you can focus on that. Same goes for APIs if you prefer backend development, or if you have friends that are engineers that want to do this sort of thing. They can make use of all of these things. Payments middleware, the auth middleware. Nobody has to log in anymore. But the wallet has a key, so it can sign anything you need it to sign. So it's a lot smoother for development. And this is just to reiterate. So what that software is just the reference implementation for what a wallet might look like. So you can, log in, generate keys using your phone and a verification code, OTP, and the password is kind of standard. And once you log in, it looks something like this. And we have things like identity-based payments that use that overlay infrastructure. So this is what actual, end users would see. What's happening in the background here is there's an overlay that stores tokens that you can register associations of handles with particular public keys. And so when you look up Deng, which is my handle, the lookup resolver finds the transaction in the overlay, pulls it down, does SPV verification on it, proving that it really is on the blockchain. It checks the signature to see that really signed that attribute. So now you know that it was me that made my public key available, so that you can send me 1/1,000,000th of a penny. So I've been throwing around the term SPV. Does anyone in the room know what that means? Yes. Nobody else? Oh, okay, well, this, I hope, will turn that around. You will understand SPV in a few minutes. So the general idea is we want to be able to send somebody a transaction and for them to be able to validate it, or at least their device, right? So the common misconception is that you have to send a transaction up into blockchain, which is kind of cloud-like, and that it tells you whether or not the transaction is valid. And it's not quite like that in reality. SPV allows you to do, brief aside, we did a project a couple of years ago for an island, Tuvalu, and one of their issues was connectivity is infrequent sometimes. You want to be able to do cash-based transactions, one person to another person's phone. You might not have internet when you're doing that. So this is the perfect use case for something like SPV. So we want that person to be able to prove that transaction is true without having to download every transaction ever and validate that it's part of that set, which could be huge. It was 11 terabytes at the time. I made this slide. I think it's even considerably more than that now. So what I mean by verify things really specifically is we run script evaluation. I had a little demo in there, but given the audience, I don't think we need to go that deep. After, if you're interested, but we check basically that the signatures are all correct. We check that the sum of the satoshis in is greater than the satoshis out, because we need to pay a tiny fee to, well, Teranodes to get the transaction included. And each input must be associated with a Merkle path. So I'll explain that. This stuff is not that important, and I don't have time to go into that. So we have a transaction, we have a Merkle path, which you can think of as just like proof that the transaction is blockchain. So here's how it works. There are block headers, and that is just the first 80 bytes of which gives you a little hash. So you mentioned hashing. It's a hash of all of the transactions that were put into the block, and it's tiny. Block's huge, header tiny. So that's what's in it. It's a reference to a previous block, and the lots of zeros means somebody spent a lot of energy changing a really low value. So that's what mining is basically. So this proves that the previous block had proof of work done. You know, all proof of work is, we've established that. And so the Merkle root is a sort of integrity check on all the transactions that are in the block. I'm seeing nods, so you guys probably know all this stuff. But this is the chain of blocks. It's the chain of headers. The Merkle root kind of looks like this data structure. That's the transaction I care about, or perhaps Bob cares about. those yellow things are all I need to prove that that blue thing is in that pink thing. And I'm to a specific block, and all I need to do is check, is that pink thing, is that blue thing plus these yellow things, does it arrive at that Merkle root, and is that Merkle root the one in that block header? So that is how you do a Merkle proof, in short. So if you know that stuff, then it's definitely valid. You can't change it. So this is just an idea of how big those data. So pretty small, 72 megabytes. You can get that on any smartphone these days, no problem. That's for all history. You probably don't need the old ones. So really just a few kilobytes. The problem is you don't get that until it's in a block, and block time in BSV is on average 10 minutes. So if you send a transaction, you're going to wait on average 5 minutes to get one of these things for that. So what we have to do is actually include the parent transaction for this, and usually the parent transaction is already in a block. So then we're doing chains validation. So what that looks like under the hood, a bunch of bytes. So you can take a look at that in your own time. So this is just an example of what a Merkle path looks like in hex. Here is the most recent transaction. It does not have a Merkle path yet, but it does have an input hash, and if you hash that, it should match that. That's one of the checks we do. Oh, let's switch that off again.
Probably you are pressing some button.
Oh, am I?
Yeah.
Oh, there's an unmute button, is there? I'm sorry. Okay. It's flapping too much, obviously. Okay. So let's get that horrible mess off the screen. Really, so what I'm saying here is that we know this one is definitely valid because it's in a block. These ones we know are valid because we can run script evaluation and proof that the inputs are in a block. And so I can keep building this blue chain of new transactions until the next block is found and they kind of turn green. So that's the order in which we verify a transaction. And for those of you who have dealt with the blockchains before, you'll know that one of the things that we can't know is whether or not there's another transaction that looks like this, and that has a blue transaction on the end of it that's actually a different transaction. So like the double spend thing, where I'm paying C and aus. So the way we resolve that is interpersonal communication. Bitcoin is this sort of economically secure system, right? There's no sort of definites. It's all probabilistic. Does that work? Great. Okay. I know how to scale it now. Oh no, I don't. Hello. Sorry. Okay. So interpersonal relationships, as in, if I'm in Tuvalu and I'm trying to pay someone with electronic cash, they're in front of me and I have been speaking to them and we know who each other are. So this whole, there's a crypto hacker that's going to steal your money thing isn't really relevant in that context. So if we're making trades one to another, even if we're doing it like, I don't know, over emails or Slack or something, we're secure in that we would immediately know within about 2 seconds that the individual that gives the transaction is trying to defraud us. So even in the sort of coffee scenario where you're just buying a Starbucks or something, they would know in 2 seconds that you're trying to defraud them. So it's not a realistic scenario that we have to worry about. Okay, so just quickly again, Alice to Bob sends a new transaction to him. He might send it to a specific overlay. That overlay would then propagate it to Terranode, which would then mine it eventually, send the Merkle path back to the overlay, back to Bob, back to Alice, and now everyone's got green transactions. They're good to go. I don't think we should do this today. Does anyone want to do elliptic curve math? No. Okay. Let's just skip through this. This is how you could do key derivation between people.
Send slides.
Oh yeah, you can look into that. That's good fun. And this is an example of locking script, and this is how script evaluation works. If you want a demo of how it works, you could run through each operation. It's a 2 PDA for anyone interested. So more practical, this is how you would actually use an overlay. So you can, again, just use our SDK as a topic broadcaster, which means you take your transaction, you give it to a specific set of overlays as defined by a topic, and you can make up your own topics. You can run your own overlays for your own specific purpose. So just to give an example, one developer has produced kind of like a Spotify type thing, decentralized, where everyone really owns everything, and you can, pay as it streams kind of thing, because the payments are so cheap. You can do that per packet. So they have an overlay that is TM_music, for example. Music content owners can make their music available on that overlay. And then to look it up, you would just replace the hello world with LS music and list the songs available. And that means that like multiple like UX designers could give you front-end apps that hooked into the same data, because the data is all on this overlay that anyone can access public. It's like a public shared context without having to go validate all million transactions per second. You just got to deal with the particular topic you're dealing with. And this is how I showed you the identity resolution stuff. This is how simple it is in code. You just resolve by attributes, username, Megan. That's it. And then it will go get you transactions, do the validation, give you the public key essentially. And here's the code. So I wasn't sure what the audience would be like. And you can do this with distributed storage. So that UHRP is a universal hash resolution protocol. You get some data and you hash it. That's the kind of what works as a universal identifier for that data. So if you upload that to multiple services, you can always use that hash to identify it. So we have a system of distributed data storage, much like thank you, IPFS. Yeah, it's equivalent to that. So really, the data is just being stored in S3 buckets or your own hard drives, and you can make that data available in exchange for payments through the middleware if you want. So really hammering this slide. So we're just coming back to that. A couple more cartoons to help visualize what this might look like. So a specific topic. You submit the transactions, you look them back up again. And you focus on your own domain. I think that's pretty much it. There's some architecture stuff here, but this like background reading, I've already spoken about most of this, I think. So yeah, thank you very much for your time. And thanks.
Okay, any questions? I might start.
Yeah, go ahead.
Someone else will have any questions. So if I understand correctly, you keep the same consensus as the original Bitcoin protocol. So my question is, do you still have handmade
Yes,
blocks?
it's all the same.
On average, yes.
Yeah.
Okay.
It's more the same to the Bitcoin from 2009 than the BTC of
Than anything else. Yeah.
Okay.
That's the intention, at least. Yeah. So like over the past 16 years, there's been tweaks here and there. I mean, obviously that wasn't us.
Yeah. And then right now, I guess it's the same. It's 1 hour, around 1 hour on average.
Not really.
I wouldn't really say that.
No.
That's a choice.
I'll try to explain it from a non-technical perspective, and I'll say you can.
Okay.
So essentially, so what you have in BTC Bitcoin is they're replaced by fee consequence. You can pay more fees, and then you can replace an initial transaction. So that means that the finality is depending on how deep is the blocks. That isn't in BSV anymore. So essentially what you have, and we've done this with work with companies, for example, in Argentina, they were actually working on other chains, and finality essentially instant, right? Because of the way that it's deterministic. Once it's spent, you cannot spend it anymore, right?
Yeah.
So it's about, and then it's more about trust. Like if you're doing simple transactions, the cost of fraud doesn't justify the efforts to actually try to spend it. Say you would at one point try to buy a Ferrari with on BSV, and you want to have some certainty, right? Like higher risk transactions, you may want to just, as a business model, introduce a non-defense. So that's my non-technical interpretation.
Well,
You guys can dig into.
no, I'm gonna stay non-technical because I mean, I think one of the mistakes that a lot of other blockchains have been making over the last 10 years is looking at this problem as a purely technical problem. It's not a technical problem. You can't solve everything with technology. That's just impossible. But there's an economic aspect to this as well. So I was just if I go to Starbucks and I'm buying coffee, I don't know, in Switzerland it's $10, it's probably £5 there. It's very expensive. Whatever, it's 10 pounds. You're paying £10 for something. That's not a big number. I mean, they're using credit cards, they can be charged back. There's a risk in doing business, and there's risk here as well. There's something you can never completely remove technically anyway. So if you're buying a coffee for £10, you think, do I wait 2 seconds for that signal for a double spend, or do I have to wait for a block? Probably not for a coffee. I don't have to wait. So I can just immediately take the transaction and a customer leaves the store. But if you're buying a Ferrari, you make that decision, you make that business decision. It's not a technical decision. Yeah, I'm going to wait for 10 confirmations, or I'm going to wait for 2 hours, or even whatever that is. But Satoshi wrote about this in the beginning a lot. This is not just a technical system, it's also an economic system. And I think a lot of us technology people sometimes forget that as well.
Yeah, I'll add to it and just say, well, the purpose of this is that you should be giving the counterparty all the data they need to be able to validate it themselves, insofar as they can, validate everything that is possible to validate. And the difference is that isn't done on any other blockchain. That nobody else has done that, and that would be faster even than Visa, because Visa has to make a remote call because it's account based. This is token based, so it's like you literally just give the data to the counterparty, they validate everything, you're good. So it has the potential at least to be faster than anything ever.
Good ones.
No, it can't, because of what you were saying. Is that because
you have to send it
because of the reputation damage and so on. There's no economic incentive for someone to double spend, because within 2 seconds it's going to be revealed.
And so what people often forget, if you use a smart contract or something like that, code is not law. No judge in the world that will allow you to say code is law. I wrote this code, so now I'm above the law and can do whatever I want. If there's a smart contract here and it does something and it's actually not legal, or there's proof that some funny business happened, you can go to a law, to a court, and go to a judge, and they will only rule that. It doesn't matter what's on the blockchain. So if I do something on the blockchain and say I'm going to buy his house and there's some cheating, I'm not going to own his house just because it's on the blockchain. That's that. So that it's technical, economic, and legal aspects. I mean, and our position has always been that the blockchain it fits into the legal frameworks that are already there. There's nothing different about tokenizing something on a blockchain or writing a piece of paper that says you now own 10% of my company. It's the same thing. There's laws have been there for hundreds of years. It's the same.
You raised discussing this is that you're handing over evidence of your own fraud if you're doing that. Yes, you signed something, you gave it to the person you're defrauding.
Yes.
Like there could be automatic systems to deal with, making good on projects like that.
And so if you go to Starbucks and have a £10 fake note,
right? It's equivalent, yeah.
And they don't see it, and I walk away. They'll find out later, but they have no idea who I am. So cameras, but in this case, I've actually digitally signed it. And because I have a digital signature on there, you can actually start tracing. You probably won't do that for a coffee, but you can trace that back, and then you'll find, that person actually bought these coins at some exchange, something like that. That's KYC. We know who that person is. You just fraud. So trying to is kind of meaningless because we already have laws. If you don't have laws, the system is meaningless anyway. It's not so.
Any questions? Yeah.
I have 2 questions. The first question is we stated you store we stated you store the data of the share on the third party server. And what if for example, maybe like AWS server go down, what will happen to the next block?
Well, I mean, but this is why it's a distributed system, right? So there will never be just one node line. Or I think there is some analysis done on block rewards and the money, and I think it comes down to there will probably just be 10 miners in a long time. In the end, now there's like on BTC there's thousands of nodes, Ethereum thousands of nodes. I think we have hundreds. Actually, parts of doing that.
There's
Probably
thousands of nodes,
yeah, so
about 5 nodes really.
but there's multiple copies of the data.
Yeah.
So when we were running our test lab on Melon TPS, we were running only 6 nodes, but they were all in different geographic locations. So it's come in the US, we had one in Korea, we had in Canada, and Europe, we had in Singapore as well. So if one of them goes down, you have 5 more copies. And that's the nice thing about this is that the data is immutable and it's all the same. The transaction doesn't change. The block doesn't change. None of it, the block error, none of that changes. When that has been finalized, it's the same forever. You can actually move that data somewhere else. You can always cryptographically verify that it's the same.
Yeah.
So if somebody changed the transaction, it doesn't hash into the same, or you can't hash it into the same hash. It's going to be different. If you do anything to the block, you change one little bit, it doesn't hash into the same thing. It's different. So you can verify everything from the inputs, outputs, transaction blocks, and the whole chain cryptographically. And therefore you could theoretically put the data anywhere you want. Doesn't matter. You can always verify. And we have multiple values.
Thank you. And another question is that I saw your like reward mechanism, like it's the same with the Bitcoin reward that you have block reward, and in the future you're gonna rely more on the transaction fee. But you mentioned that your transaction fee very low.
I noticed that in the diagram, it's kind of misleading. I think it just means that when you're doing 1 million transactions per second, even though the fee is tiny per transaction, it adds up to enough to cover the block reward.
So the point is that you need to scale to that.
Yeah, you have to have the transactions go up. Otherwise, I mean, 7 transactions a second and 30 millionths of a penny per transaction. It's not a lot of revenue.
No, but I think there's also another idea there as well. In that why this is going to take some time to happen is if you're doing 7 transactions a second, I think we would get send millions of dollars where we pay a couple of thousands and we keep a couple of dollar fees. That will never scale into the use by everything. So that is always going to be limited. There's going to be a limited use for something. It's fine. People playing with lots of money. Okay. If you want to get into the scaling bit where we actually just rely on the fees, which will happen fairly quickly. I mean, this is going down every 4 years, the reward. You need to incentivize people to start using it more, so you have more reliable stream of fees coming in. So our payments should be doing this. Our interaction between companies should be doing this. Whatever, all that stuff. Then you have a reliable, hopefully 1 million transactions a second, and you have a reliable income for the miners. That's not going to be the case if you limit it to a certain level. Even if the fees are higher, it's going to be much less reliable income for the miner, and therefore the system, in the end, is not going to work. It's not sustainable. And so, just giving you the calculation. So BTC price now is $117,000, $110,000. We're going to have a halving in 3 years, and then 4 years later, and then 4 years later, and 4 years later. If the miners are going to be earning the same because the hash is the same, security of the network, right? That's what they talk about. That has to double. That has to double every time. So in about 5 doublings, how far are we? You're into a lot. It's already $2 trillion. So the next double has to be 4 trillion, 8 trillion. You're talking about trillions of dollars. I think if my math is not wrong, it's like in 20 years. It's bigger than the whole global GDP. I don't think that's realistic. Yes. And no, let's keep on. We double the global GDP. That's the way that network will work. So it's inevitable that will fail. It's just not going to be tomorrow. It's going to take 10 years, 50 years, maybe 20 years. It's going to take, but we can't sustain that. If we go to the other model of transaction fees, that's just usage, right? because then the reward is going down. We don't care because we're getting paid by users. So we're still getting paid the money that's needed to secure the network. But that's very, very long-term thinking. That's why we're still here, even if we're not the most popular blockchain. But we have this longer-term vision of if you want to have this system work, this is the way you have to do it. And this is going back 10, 15 years. You go back to I don't know if you guys have heard about the Bitcoin Talk forum. Still unless Bitcoin Talk. It's Bitcoin Talk. You can actually see Satoshi was active on that. He was discussing with all the main developers in 2010, 11, maybe earlier.
Allegedly.
Allegedly, he had a handle Satoshi, and he talks about this that the only way that this is ever going to work long term, income from transaction fees actually goes a lot higher than the block reward, and that's a graph. The reward goes down, fees go up, and then you have a system that's imbalanced. And I think he slightly differently, but it says we're either going to have massive volume at all, and it's all going to end up in data centers. I think it's another quote basis. So it's not going to be Raspberry Pis at home. It's going to be data. It's Googles. It's the Googles, the Ciscos, the AWSs. They're going to be running massive, huge nodes. And we as people, we have a way of transacting with each other and businesses very, very cheaply, very fast. That's the point. And it's all back there. You can read all that stuff.
Yeah.
Well, NFTs implemented on BSV, like
NFTs?
Bitcoin. Bitcoin use ordinal theory, right?
Yeah. So
BSV
in fact, exactly that protocol. Yeah.
has-
Sorry, go on.
BSV use the same thing like a ordinal theory of
The same, yeah. They're the same protocol effectively, but slightly less constraints. So the ordinal protocol, if you think about just as a specific shape of data and a specific type of locking script. Have you used it on other things? Yeah, okay, so you know what I'm talking about. So if you look up BSV 21 or one sat ordinals, you'll see some documentation explaining, how the same thing effectively works on BSV. Yeah, the only difference is what I think Alice mentioned before, or one of you mentioned, you can do it with one sat rather than 546, which I think is the dust limit on BTC. That means you can make a lot more. In fact, there were millions at one point of different tokens, and yeah, on BSV, yeah. Now, actually, that company made a US dollar stablecoin on that protocol, MNEE. It's a US dollar stablecoin using ordinals, basically. Yeah.
Any other questions?
Yeah.
Final one.
So what's the actual speed, right? How many transactions per second is BSV processing right now?
Not the same. You can look it up if you go to whatsonchain.com. I don't know what it is today. It depends on the actual one that they're using, right? But the reality is that on average, I think it's around 10, I think 20. So it's not really, has really come to life. And it's essentially what I told at the beginning, that also just the promise of blockchain. People haven't really, or enterprises haven't really picked it up and started using it. So it depends. So the record, I think, is at one point, one day in time, they did 152 million transactions in one day. I think the biggest block is 4 gigabytes, but it depends on the actual needs of the businesses, right? So if you would go on what's on chain, it fluctuates somewhere between 5 and 20, and then there's peak, and then there's differences. So it's a bit what Siggi said. It's chicken egg thing. So now what we actually do with this is prove that it can scale, because by proving that it can scale, that way you can attract businesses, because they know they'll be able to build their business resilience on top of this, knowing that they're not going to land into issues. If you look at last week when the coin price dropped, I think the Ethereum gas fee went up to like $200, $300, $400 or something, like something mind blowing. That is fluctuating just because the network was adjusted, right? And essentially what we're proving is that will never happen on BSV. But again, the actual TPS depends on actual usage, right? And we're also not, it's not being artificially inflated. It's just what it is. But now we're sort of telling the world this blockchain is ready for global scale. Start doing on BSV. That's where. Yes.
But you also look at projects that are out there, so like the government. I think it was the UK government where they get a request for proposal, a request for CPC. And so one of the requirements is, I think it was 100,000 transactions.
It's not more. So at one point, that was 2 years ago, I think it was a tender from the UK government, and they were looking at the blockchain suitable for the digital account. I'm not sure where it is at the moment. But the minimum requirement was 250,000 transactions. Not many blockchains that came to that.
Well, it's not happening today, but say we're not going to build it if it cannot handle 250,000 transactions a second. So that's why we're doing it to prove that it's there, so this business can actually come.
Thank you so much. We're going to stick around. Very curious to hear your story. If I may, one sentence just to finalize. Since we've taken over the lead of the association, we're starting working more and more with universities, but also with students. So if there's any type of appetite from you guys to work with us, be it an internship, be it a research project, whatever, feel free to reach out or to tell me directly, and we can coordinate that. But we're very excited because you guys are the future, and there's so much potential. And like I said, blockchain hasn't delivered on its promise yet. It's gonna change the world. I'm convinced. So don't hesitate to reach out, connect on LinkedIn or whatever. Thank you.
Thanks a lot.
Thanks.
Okay, we are going to take a very short break, like 5